So I wanted to talk about this again, and I want to talk about Pythagoras because when people are talking about Pythagoras, they're always talking about a squared plus b squared equals c squared. You know, 3, 4, 5 triangles, etc. I only say 3, 4, 5 because that's the actual triangle that has built so much of the Western world. Because carpenters use it all the time. They have a tape measure, 3, 4, 5. They know if they're square, you know? That's one of the most powerful. It's three numbers, 3, 4, 5. And if you add them up, there are only 12. Such a miracle, really. 3, 4, 5 built the world. 3, 4, 5 built the world, really, when you think about it. But yeah, also there are I call them Pythagorean bricks. Like a cube is a brick, and a cube. See, this is one of the things I'm trying to figure out lately. I guess I haven't really looked into it that much. I've mostly just thought about it, but like a cube is a hexagon or a hexa polygon. I forget the difference between a two-dimensional shape and a three-dimensional shape, but a cube is a six-sided shape with equal sides, but also if you put two tetrahedra together, it results in a six-sided shape with equal sides also. It's almost like the missing link of Platonic solids, because even though it's a tetrahedron, or even though, like, I don't even know what to call it, but like if you put two tetrahedra together, it creates 6 triangles. Like a tetrahedron has 4 triangles of equal sides. But if you put two of them together, like the ones in the middle cancel out. So instead of getting 4 by 4, you get 3 plus 3, so you get 6 sides. But it's not quite. It's only symmetric, kind of on one pole, versus other Platonic solids that are equal on other poles. But the shape that can be conceived of as being constructed by two tetrahedra put together, it's a special shape. It's almost like the number 2. Like, 2's a prime number, huh? 1's not, but 2 is. And then 3, okay, we understand why 3 is. We understand why 5 is. We understand why 7 is. But to be perfectly honest, I'm coming around to it, I guess. Maybe I have a disagreement or two, but like, 1 isn't a prime number, and 2 is a prime number. But maybe we have our lemmas wrong, or our assumptions wrong, or our givens wrong. Assumptions, lemmas, right? It's actually like lemmas that determine what a prime number is and what a prime number isn't. And our lemmas are very close. Our lemmas cut close to the bone, but not right up to it yet. Maybe 1, 2, and 3 all don't belong. Maybe 1 and 2 completely do not belong. Maybe 3 is the first number. Maybe 4 is the first number. There's a compound number. 4 points to a tetrahedron. Maybe that's the first number. How are numbers exactly constructed? We're still working on it. But what I was trying to get to with this is, all right, I'm just going to pause for one little second. Yeah, so what I was going to say is that, talking about this object, so I'm in the middle of proving this point right here. I started right here, and I've gone all around this thing proving all these points, and as of today I'm on page 107. I just started 107. I also worked on 106 today, and I also worked on 105 today. I can't remember if I worked on 104 today or not, but I'm almost halfway there. But I'm using very primitive math, but the numbers are getting big. But I'm still so impressed with it every single time, because I can't make sense of it, but like I prove it this way and that way, like, and it's all just numbers and really, really simple math, really simple algebra. I'm doing everything with like, if you take geometry 1, the geometry I'm using, you like, as a sophomore or as a freshman, I took geometry 1 in high school when I was like 14, 15, 14. Or maybe even 13. I can't remember. And definitely within the first month, I learned enough geometry to do what I'm doing. And I already knew, like in 8th grade, enough geometry to do what I'm doing. Which might not prove to be that impressive if this isn't what I think it is, but I'll learn a great lesson if I'm wrong. Diligence. This is such a beautiful thing that if I disprove its existence mathematically as an absolute object, then I will do myself a great service to serve the truth of order over nearly perfect beauty instead of perfect beauty. I'm researching this because I think this might be perfect beauty, a piece of perfect beauty. And if I'm wrong, I want to know about it so I can get rid of it and go on to perfect beauty. But this little fella is a contender. So anyway, what I was saying about Pythagoras before is like Pythagorean bricks. It's like 6-sided objects, whether they're a cube or a brick of any length, any height, any width, whatever, just a brick that's perfectly square in 3 dimensions. And calculating this object, like bricks are about Descartes, but these triangles are about Pascal. That's how I think about it in my mind. Pascal is inherently more Trinitarian and triangular, and Descartes is more cubic, which in one sense seems to be against triangularity, but on the other sense, it's still It's so funny, like a triangle, three sides, but then you got Descartes, who's kind of like anti-triangle because he's so square, but he's really so cube. And then that's three coordinates, which is a trinity of a different kind. It just depends on the directions those three poles are pointing. How flexible. But yeah, so what I was saying at the very beginning is, a squared plus b squared equals c squared. Anybody who's done any math at all really pretty much knows that. But even more important, in three dimensions, a squared plus b squared plus c squared equals d squared. And what I love about that is both are Pythagorean. Both are talking about the exact same principle, even though it's a little more interesting in the three-dimensional sense because you're getting a diagonal that cuts across three-dimensional space instead of just cutting across two-dimensional space, which is awesome. But what I love about a squared plus b squared equals c squared in two dimensions, and then in three dimensions, a squared plus b squared plus c squared equals d squared. What I love about that is it's two of the simplest mathematical equations that exhibit the fact that nomenclature is far from perfected. Because the c in a squared plus b squared equals c squared is different than the c in a squared plus b squared plus c squared equals d squared. But if you had two expressions of Pythagoras, you'd have a squared plus b squared equals c squared, and you'd have a squared plus b squared plus c squared equals d squared. That's what you'd have if you're talking about Pythagoras. And if that's all you had, and you didn't have any context, you didn't know what you were talking about, you'd see C on one side and you'd see C on the other side, and you'd think they were the same C, but they're not. Sometimes when English majors, you fuckers, talk about this shit, I only say that because it's gotten out of control, but where's Virginia Woolf, right? People talking this, people talking that. Where's Virginia Woolf? Where's Anais Nin? Remember there was this French writer, Annie Ernaux. Annie Ernaux or Anne Ernaux? Ernaux. It's sad I went there. I'm sorry. But yeah, one C don't equal the other C. So we have a problem with nomenclature. People call it, when we're talking about English majors, semantics. The meaning is lost in semantics. The meaning is lost in translation. But meaning can be lost in translation even when you're speaking the same language. If you've come up in different intellectual or pseudo-intellectual traditions. That's pretty much facts. But yeah, it's cool that this thing is totally not Cartesian except for what I'm trying to figure out with these two planes, and that I can describe, like, what I like about this page of math. This is a really sweet page of math. It's my 106th page. I just completed it. Took a while. Looks like kindergarten scribble, but I don't mind saying that at least I have the gumption to long multiply till I die. I'm gonna long multiply till I die. Why? Because I have a record of every single number. Facts. Sorry. But I like the thing I'm trying to describe. I'll see if I can point it out. This line right here. At the bottom of this purple triangle. This line right here. This page is meant to prove that this line right here of this purple triangle, this bottom line right here, between this point and this point, I have all the coordinates. I have the difference between those coordinates. I perform the three-dimensional Pythagorean theorem on them, and then truth comes out. And what's truth? One unit. But anyway, I still think it's cool because it's still miraculous. Because I don't understand exactly how it works. I only have notions. I think this is awesome. So I'm proving this line right here. This line right here is what I'm proving. I'm sorry for being too proud about it. I just think it's really awesome. Like, I'm not doing it. The numbers are taking me there. I have no choice what these numbers are. I have a choice at the very beginning of what these numbers are. As long as I define them perfectly, geometrically, whatever those coordinates, as long as this is a perfect equilateral triangle, it doesn't matter how I define these points, so long as I define them in a plane. After that, everything else is predetermined. It builds itself. The only thing you have to do is good accounting. You don't have to be brilliant with this or that. All you have to do is account. That's it. A wee bit of geometry. A wee bit of algebra. Very, 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 very simple principles. Like 6 little itty-bitty principles. And the whole thing builds itself. And then it continues to build itself. And from there, it's just, or at least that's the idea. It looks so beautiful to me, but I could be wrong. So I need to know. Because, yeah, this is just a piece of the puzzle. But if I can prove this piece, I prove the whole puzzle. I kind of broke it down to that. But also, if I disprove this piece, I disprove the puzzle. And then I can move on to... Whenever I've had to abandon a beautiful pattern, it only ever meant that a more beautiful pattern. Like, it would break my heart if this pattern is not perfect mathematically. I'm almost halfway there to figuring it out. And it's been a slog. 106 pages. A stupid little baby kid shit scribble that looks like this. And it's only going to get worse because the numbers are starting, in my mind, to explode, which is what I wanted to get to, right? Because this is kind of cool. Because what I'm about to say is going to equal 1. Get this. So I'm going to use parentheses and close parentheses when I'm talking about a fraction. So parentheses 53071 over 118098. I'm sorry. 53,071 over 118,098 close parentheses squared plus parentheses 547,913 root 3 over 1,062,882 close parentheses squared plus parentheses 6,302 root 6 over 531,441 close parentheses squared equals 1. Excuse me? Let me say it another way, because that's a little further down the proof, so to speak. 76,046,338,107 plus 300,208,655,564 plus 317,572,715,308 equals, oh wait, no, that's the wrong number I used there. Uh-oh. So I come up with 372,515,715,308. 8, 7, 3, 9. Where's the 9? Times 4. Sorry, I gotta look up the math. 8271784943148878827 376572715308308. I did some math wrong, I think. But this part's right. This part's right. But somewhere crunching those numbers, but when you have 12 decimal points, it's hard to keep up with every single digit, every single number, every single bit. It's like, wow, I got 300 billion bits here, so, give me a break a little bit. Oh, wait, 317, no 6? That doesn't make sense. 376, 39, 317, 721. Oh. 376, 317. Oh, 721632. Yeah, you gotta erase shit sometimes. 317. 721 632. So that's what I changed. That part right there. So it should have been. I'm such an asshole. 76,046,338,107 plus 300,208,655,569 plus, and this is the part I changed, 317,721,632. And that equals 376,572,715,308 over 2 squared times 3 to the 23rd, which equals 376,572,715,308, which equals 1 over 1, which is my a squared plus b squared plus c squared equals d squared. My d squared equals 1, so my d equals 1. My d squared equals 1. My d equals 1. My d squared equals 1. Therefore, my d equals 1. If my d squared equals 1, my d equals 1. You know what? D squared equals 1. D equals 1. It's convenient. That's why I built it that way. Easy. Everything built out of ones. 1, 1, 1, 1, 1, 1, 1, 1. Ones everywhere. Sorry, I'm just trying to fanboy. I'm fanboying myself on my better instincts, hoping that my better instincts can save me from my worse instincts, because so far right now, my my worser instincts are winning. But my better instincts have had a good rally, I think. And maybe we can rally higher. If we don't, we're dead for sure. Of course life is worth fighting for. Like, logically, duh. But as I age and as I get older, it's kind of a little more like, well. That's kind of sad. But it comes and goes. At least it provides perspective. But you can't ever give into it. I just think it's cool that these crazy fractions add up to 376,572,715,308 over 376,572,715,308, which is 1. And that's that proof of this pretty little line, which means that I'm on track to figuring out what this object is. Sad in many ways, but interesting. If I win, to me a win is that it's true. But I'm trying to reconcile myself to the idea that if the numbers that I think this possesses I do not come to, I'm trying to convince myself, or I'm trying to make myself understand that that's also a win, because I will immediately, there are many shapes I'm in love with, and there are many shapes that have very, very, very fertile ground. But I have to know about this one first. And whether it is what I suspect it might be, or whether it's not, pretty much I already know what my next project is. So either way, once I know or once I know not, or know it's not, I can cut loose and go on to the next thing. So I just want to get this fucker done. It's a little bit like climbing a mountain in a certain way, because it's like every morning, every night, I have to do a stupid page to get to like creep along this surface, this silly shape. To my mind, if it is technically speaking a shape, then I think it's a quite nice discovery. If not, it's a very stern lesson. I thought it would take me a month, 2 months tops. Now I'm thinking, I'm already It'll probably be a year. It'll probably be like 250 pages. My first estimate when I first began was like, oh, it'll be 80 pages, 100 pages. I'm well beyond that, and I'm not even halfway there, so yeah, solid 250. Brutal. But then I don't know. Sounds so stupid. What a stupid thing to make a video about. Ta-da!